So when you do something like this, they've written the division out, but remember division can also be written like this. So this is how I would write this particular one. I would write it on top of each other. And remember, you can reduce inside to inside. So the first thing I'm going to look at is says what goes into both 8 and 14. So what does go into 8 and 14? 2. So I would have 4 and I would have a 7 here, right? And then what can the x to the 4th and x cubed? I can take 3 x's out, right? So I am ending up with just 1 x on top, right? We subtract. And then for the y, I have 3 y's on top and 5 on bottom. So that's going to end up with 2 y's here on bottom, right? So far, so good. All right. Then I'm going to look at them individually and say, can I reduce any of these individually? So when I look at this top one, 4 is a perfect square root. So I can take that out. What is the square root of 4? 2. And then I just have the x left in the root. 7 does not have a perfect root, but what does? Y squared can come out because that is just y if I take the square root of y squared. So now I'm left with this, 2 square root of x over y squared of 7. My final step here is that I do not want to leave a radical in the denominator. So to get the radical out of the denominator, I multiply by whatever I need to multiply by to get it out of the denominator, right? Which is the square root of 7. So now on top I have 2, and inside the root I have the 7 and the x. On the bottom, by multiplying it by the root, it actually gets rid of the root. So I have the 7 now on the outside, and then I also still have that y on the outside, which is how we ended up with that. All right, so again, I'm going to write this just like I did the first one. I'm going to put numerator over denominator. All right, and then same thing. I can subtract here. They're both inside, so I have 3 r's on top, 1 on bottom. I'm going to subtract, and I'm going to end up with 2. 2 s's on top, 1 on bottom. I'm going to subtract, and I end up with 1. And then those t's actually cancel. T over t cancels to just the number 1, right? And so I have this. Now I'm going to look and see if I can simplify this. Well, I have a squared inside a square root, right? And so remember, if it groups according to my index, I can take it out. So that means the r can come out and the s will stay in. So we have done multiplying and dividing with radicals. Now we're going to look at adding and subtracting them. When you're adding and subtracting, you're actually looking for the same concept as when you add and subtract variables. When you add and subtract variables, they have to be like variables. So they have to have the same variable with the same exponent. When you are adding and subtracting radicals, you have to make sure that the number inside the radical is the same and that the index of the radical is the same. So just like we have 2x plus 3x, that is 5x. If I have 2 square root of 5 plus 3 square root of 5, that is 5 square root of 5. I just add my coefficients pretty much is what I'm looking at. I'm adding the number on the outside there. And so the first thing we're going to make sure when we're adding radicals is, are they alike? If they are not alike, just like with variables, you cannot add them. But if they are alike, you're just going to add the numbers on the outside. Think of it like this. I have 2 square root of 5s sitting here and 3 more over here. I have 5 altogether. As long as they're the same, you're just adding them up, okay? And so if we look at this first definition here, like radicals are radical that have the same radicand, that is the number inside the radical, and the same index, that is the little tiny number on the outside. Remember, if you don't see an index, it is assumed to be a 2. All right, so like 2 square root of 5, 3 square root of 5. The index was 2. The radicand there was 5. So as long as those are alike, you can add them. Let's look at example 1. So my process here is I want to first make sure that my radicals are simplified. Once they are simplified, I find any that are alike and I combine them. So if I look at this first one, 4 square root of 3 and 2 square root of 3, those are as simple as it gets. 3 is a prime number. I cannot take anything out of the root. These are the same radicand. The 3's are the same. And the index, remember if you don't see it, it is a 2. Those are the same. Since those are considered like radicals, all I have to do is add the numbers on the outside. So 4 square root of 3 plus 2 square root of 3 is 6 square root of 3. Before I start, I need to make sure that I have simplified radicals. Because if I just look at this, it doesn't look like I have anything that is the same. And so what I'm going to do is I'm going to take these and I'm going to first do my factor trees to see if I can make them any simpler than they are. And so I'm going to factor, so I'll say 5 and 9, 3 and 3. Then I would say 2 and 9, 3 and 3. And then that is as simple as it gets. That's just a 5. All right? And so this first one, I can group this 3. That's going to come out. 5 is going to stay in. Make sure you bring down the plus sign. This 3 can come out. This 2 will stay in. And then this is as simple as it gets. And so now I'm going to say, do I have anything that's alike? Well, yes, these are considered like radicals. So I'm going to combine those. Remember, my coefficient when I don't see one is just a 1. So I have 3 square root of 5 minus 1 square root of 5. That gives me, why did I write a 5 there? Let's see. Yeah, that should be a 2. This is a 2. When I add those two, 3 plus negative 1 or 3 minus 1 is 2 square root of 5. This is not like 3 square root of 2. That is not a like radical there. So that's actually going to be my final answer. I cannot combine anything else. These are not alike, so this is my final answer. All right, so all of these are simplified. If I look at 3, that is a prime, 2 is a prime, 3 is a prime. So then I'm going to look and see what do I have in common. These are like, so there's a 1 in front of each of these. 1 and 1 give me the 2. I cannot combine this with anything because there's nothing alike, so that's where I'm going to get those. All right, so let's look at this example. The first thing I want to point out is that the index is now a 3. So when I'm simplifying these, I'm going to look for things that group in 3s. They're all index of 3, so if they end up being alike, my index is the same, but right now the radicands are different. So I'm going to try to simplify these based on groups of 3. When I look at this first one, this is just a 5, so that's not going to simplify at all. I'm going to then look at the 40, and I'm going to do my factor tree here. All right. So this is going to stay negative 8 cubed root of 5. This one, I already have a 9 on the outside. I have a group of 3 that can come out. So times 2, and then I cubed root of whatever is left in, which is going to be a 5. And then let's look at the last one. You can see that 5 is going to go into it because it ends in a 5. So this is also going to have a group of 3. I already have a 2 on the outside. Make sure you pay attention to that plus, that minus. So we're already going to have a 2. This 3 can come out. And then I also have a 5 that stays in there. So I made sure that all of those are simplified. Then I'm going to just do my multiplication on the outside and if I had any on the inside. So this is going to remain negative 8 cubed root of 5. We're going to end up having an 18 cubed root of 5 minus we're going to have a 6 cubed root of 5. These are all like, so now I can just add these. Negative 8 plus 18 is 10, minus 6 is 4. So my answer is going to be 4 cubed root of 5. So even with larger index, you're still going to do the same process. You just have to remember how to simplify those based on your index. I'm going to look at first my numbers, and then I'm going to look at my variables. So I'm going to factor my 50, 2 and 25, 5 and 5. This was an index of 2. I already have a 2x out here. This is a group of 2, so that's going to come out. This is not a group of 2, so that is going to stay in. If I look at my variables, I have only one x, so that is going to remain on the inside as well. Then I'm going to put my subtraction, and I'm going to do the same thing with that 8. I have 2 and 4, 2 and 2. I already have a 5 on the outside, so I'm going to put my 5 there. And then I'm going to do my grouping. I have a group of 2 that can come out, a 2 that will stay in. And then I'm going to look at my x's. Remember, you can do it two ways. You can either write your x's, there's 3 of them, right? And you can say I can group one, one's going to come out, one's going to stay in. Or you can take that index here and do the little divide by 2, 1 with a remainder of 1, 1 came out, 1 stayed in. However you do it, same thing will happen. So now I have to consider two things. I'm going to simplify this. 2x and 5 give me a 10x. Square root of 2x. And then 5, 2, and x give me a 10x square root of 2x. So when I'm looking at this, the index is the same. Those are both a 2. The radicand is the same. That's a 2x. But in order to add my coefficients, I have to make sure those are like variables as well. And they are. I have an x to the first power and x to the first power. So this actually ends up being 10x squared of 2x minus 10x squared of 2x equals 0, right? Which is a valid number. That is an answer. All right, so I have to check a couple things when I have variables. I have to make sure that my radicals are like as well as my coefficients to be able to add those. All right, so let's look at this first one. The 2 is prime, so the 2 is going to stay in there. With my x's, however, I have 2, so that x is going to come out. I end up with x. My 2 stays on the inside. For my 75, I'm going to factor this one. I have a 5 that can come out and a 3 that will stay in. But right here, if I do 4 divided by that index, I get 2 remainder of 0. So 2 x's are going to come out, none are going to stay in. The next one is already prime. So when I look at this one, 3 is on the inside. I can't do anything with the 3. That's going to stay just like that. This last one I can actually simplify. So I have 2 and 9, 3 and 3. My 3 will come out with that x that's already there. And my 2 will stay in. So now I have to say, what do I have that are like terms? I'm going to start here. I have an x on the outside, a 2 on the inside. X on the outside, 2 on the inside. Those are like, all right? So I have 1x minus 3x. That's going to give me a negative 2x, and that square root of 2 stays the same. The other thing that's alike, I have 5x squared minus 2. Oh, that should be a squared. I wrote it wrong. Minus 2x squared. So that's going to be a 3x squared. And that 3 remains the same. And so when I'm adding and subtracting these, I had to actually look at, okay, these are like radicals, but I also have to make sure I can add what's on the outside. Had this been an x and a 3x squared, I couldn't add it. That's why I couldn't add these two, not just the radicand, but also what's on the outside were not alike. And since those were not alike, I couldn't add those even if my radicand had been the same. Those would not have been considered like terms to be able to combine. So I have to make sure that when I have variables involved, that not just what's on the inside, but also what I'm combining can actually be combined by my prior algebra rules. Make sense?